Good afternoon, students. So welcome back to digital electronic class. In today's class, we are going to deal the concepts of your previous class discussions. Like we are going to discuss in today's class how the combinational circuit is differ from sequential circuit. So this is the first criteria we are learning. What is a combinational circuit and what is the meaning of the sequential circuit? So before proceeding with this topic, we just want to take a previous class overview what we have discussed. In the previous classes, we talk about the combinational circuit. It is nothing but it take the different input combination and try to get the output by taking the input combinations. We have designed half adder, full adder, half subtractor, full subtractor, and even we have converted the BCD to code converting kind of concepts we have discussed. Now in this combinational circuit and the sequential circuit, the first thing what you need to understand is how to design the combinational circuit. This part we can cover already. This thing we are going to learn now, sequential circuit. In combinational circuit, what we have seen, students, so we have taken one block diagram in which we have taken the input combinations. So we have taken the combinational value of it. So combinational circuit in the sense we are taking different input combinations, like we are considering I1, I2, I3, so on. We have taken till IN, right? These are input combinations. So I1, I2, I3, I4, so on, IN. And we try to produce respective outputs. So like O1, O2, O3, so on, OM. So by taking this N number of inputs and M number of outputs, we have taken out of these all what you want to design. Like we want to design the adder, subtractor. Same thing we just want to go for with multiplexer, demultiplexer, encoder and decoder. So these are considered to be the combinational circuit. Whereas sequential circuit means here also we are saying we are considering the combinational circuit, but what we are taking extra here we are taking the memory element. In this, memory needs to be considered for designing the output. So same thing here also we'll take different input combination I1, I2, so on till IN, right? This is the memory element we are going to attach to this and we are trying to produce the output. So this is what? Combinational only. In this also we'll take the combinational circuitry, and this combination circuit and memory element is considered to be the sequential circuit. So in this, while designing this sequential circuit, what is our criteria to discuss in this particular part would be the designing one. How we are going to design the sequential part. So that designing depends upon the memory elements. What is the memory in this digital electronics? Memory means storage. What you want to store? Either you want to store ones or you want to store zeros, because our data is there in the form of ones and zeros. So by taking the ones and zeros combinations, we are going to store in the memory element. So you are already well aware of it. What is a memory element is all about? It's a permanent storage or temporary storage, depends upon volatile nature, non-volatile nature. We do have RAM and ROM, right? So those are memory elements. How those elements has been designed? That can be designed by using a concept called latches and flip-flops. Latches and flip-flops. So what is the meaning of latches and what is the meaning of flip-flops? So latches means what? Latches, how do we had a latch? Suppose you had a door, you had a latch. If you open the latch, someone can insert into the room, right? If you close the latch, then no one can enter the room. So you want to make that particular thing. So in the same phenomena, in the same concepts, we do have the latches. By using the latches, we are going to design the flip-flops. So flip-flop is also a device. So basically what is a flip-flop? Flip-flop is also used for storage. What you are going to store in that? You are going to store information, that is ones or zeros, and the specialty of flip-flop is that it can store a bit of information. The main important point what you need to keep in your mind is that whatever the flip-flops we do have, it is going to store a bit of information. So what is the meaning of that? The meaning is that it can store a bit, single bit it can store it, either it can be 0 or it can be 1. So that thing is considered in the form of memory. So that memory you want to design by using this latches and the flip-flops. Latches is also same thing. It is going to take the bit of information, but by using the latches we can design the flip-flops. By using the flip-flop we can design the memory elements, in which we do have a counters, there are different counters we do have. That particular part we are going to see by using the memory elements. So these all concepts, what all those concepts we are using, so those are going to be used in sequential circuitry thing. So in sequential circuit, what we are using, students, we are using combinational circuit. That means by taking the input combinations, try to produce the output. In this extra thing, what we do have is memory element. So that extra part what we are going to use is memory element. We are feeding back the memory elements again to the input side so as to store the data. Now this is nothing but like a feedback, you can say. So we are using the feedback over here. So by using the feedback, we can pass to the combinational circuit. By taking that particular memory elements, it's going to design the sequential circuit. Similarly, same form of combinational circuit. In combinational circuit, what we have discussed? We have discussed about, first thing we have talked about the multiplexer, right? Multiplexer or mux. Then we have designed demultiplexer or demux. Then next we have seen the decoder. Then next would be the encoder. Then we have proceed with the adders also. So in adder, half adder, full adder is there. These all are what actually. So these are the things we have discussed in the combinational circuit. So whereas in sequential circuits, you are going to learn the flip-flops. How the flip-flop is going to design. What are the things it's going to depends on. So there are different types of flip-flops. Totally, we had 4 types of flip-flops. Starting from SR flip-flop, JK flip-flop, T flip-flop or D flip-flop. So we are going to design this by using the universal gates. Why only we take universal gate, students? Because it is going to be used everywhere. Whatever circuitry you are going to see, it is going to design by using universal gate itself. Like we do have NAND gate and NOR gate. So both NAND gate and NOR gate, both are considered to be the universal gates. So whatever the flip-flops we are going to see in those flip-flops, those are going to be designed by using the NAND gate and NOR gate. So that NAND gate and NOR gate, how we are going to design and what parameter they are going to be see, that thing we are going to see now. So as I said you, flip-flops are of how many types? There are 4 types. First is SR flip-flop. Next, second would be JK flip-flop. Third would be toggle flip-flop. Next is data or delay flip-flop. So these all flip-flops we are going to discuss in sequential circuitry. So sequential circuit, we are going to design these all 4 types of flip-flops. So what is SR stands for? SR stands for SR means S stands for over here is set. Set means bit is equals to higher, that is 1. R stands for reset. Reset means if you go for normal way of doing, then bit will be 0. For reset, bit needs to be 0. That means it needs to be grounded, and for set, bits needs to be 1. So for that, it needs to be somewhat higher. So this SR flip-flop we are going to design by using NOR gate and NAND gate, right? So by using NOR gate and NAND gate, first we will design its latches. Then by using the latches, we are going to design the flip-flop of SR. So S stands for set and R stands for reset. So in SR flip-flop, there is a certain limitations. So that, what is that limitation? When set is equals to 1 and reset is equals to 1, both, when the value of both is equals to 1, then it is invalid condition. It cannot be happen, right? If set is 1, reset needs to be 0. If set is 0, reset needs to be 1. That way we can design it. But if you're getting both the values are 1, 1, then it is going to be invalid. So that invalid phenomena we are going to overcome by using JK. So JK, what the JK will do, they'll try to eliminate the condition of when S is equals to R is equals to 1, when this certain condition we will get, that is invalid condition. We try to eliminate this invalid conditions. That we can do it by using the JK flip-flop. So in JK, same we are going to use by using NAND gate and NOR gate we try to implement. When we implement, we'll go 2 kind of truth table. One is the excitation table, next is the characteristic table. This 2 table we have to understand, because they can ask in the question to first The way what we have done for the combinational circuit, first what we have did students, so we have taken first its truth table, next is block diagram, then it is K-maps, then by using the K-map we have designed gate level designing. This is the way we have done. Similarly in these also, first thing what we will do, we'll try to write its block diagram. Likewise we will draw one block and we will give input as J and K, S and R. We'll try to write the output. We say here outputs are Q, capital Q, Q and Q bar, present state and next state, because as I'm saying memory means it can have the previous states, it can have the present state, it can have the next states, right? They can have 3 states. That 3 states, how it is going to depends, that also we are going to see in the flip-flops, because flip-flop is a designing of memory elements we are going to design by using the flip-flops. So over here SR, first we will write its block diagram, second thing we'll try to draw its truth table, then by using the truth table we'll try to design by using the universal gates, that is NAND gate and NOR gate, right? So this is the way we can proceed with JK, N, T and D. So whatever the limitation is there with SR, that is going to be overcome by JK. In JK also we'll get condition, J is equals to K is equals to 1, that is called race around condition. We'll try to eliminate that race around condition by using the other kind of flip-flops. So what is a single means? T means only one inputs, D means only single inputs, whereas SR means there are 2 inputs, one is set input, another is a reset input. Here also J and K, that means we are giving 2 inputs to the given combinational and sequential circuit, that is J is equals to K is equals to, there are two inputs and give the 2 outputs. In all the conditions we are going to design those kind of flip-flops by using sequential circuitry. So we'll take the first concept students. So we are going to design the SR latch. First concept what you are going to design is SR latch, right? So in that first we'll draw its block diagram. We'll take first input, next input. What is the first input? S. Next input R, right? This is SR. We are going to get the output. What is the output we are saying? Suppose this is Q. Next output is Q bar. This is the output 1. Right, this is your output 2. These are our inputs value, right? This is your SR flip-flop. So this is your flip, that is latch. We are considering first thing is the latch, right? SR latch. So when you want to design any kind of latches or flip-flops, we can design in 3 ways. First way is by using active low. Active low. Then we can design by using active high concepts and by giving the clock pulses. By giving clock pulses we can design. What is the meaning of active low? It means when 0 is given, it is going to be activated. Means output is high. When you give 0 bit. When you give 1 active high means when you give 1 bit. That is higher bit, set bit, then it is going to activate the output and it make it as output is high. Clock pulses means we are going to give different clock pulses. This is called clock pulses in the form of square wave. The lower bit is called 0, then higher bit is called 1. 0 and 1, 0 and 1. Likewise, we are going to give a chain of bits, zeros and ones, that is called clock pulse. Again, clock pulse are of 2 things. It is edge triggered and next is level sensitive. That means this depends upon 2 concepts. Clock pulses are of how many types, students? Again, it is divided into 2 parts, A and B. One is called level sensitive. Level sensitive. Next is edge triggered. What's the meaning of level sensitive? It depends upon the levels. Suppose I am giving like this flip-flop. So it has 2 levels, students. So this is the lower level, then it is your higher level. Like this, lower level and higher level. So when we see the levels of it, this levels, so then it is called it as level sensitive. Level 0 or level 1. So lower level or higher level. So when we see this sequence of levels, then it is considered to be the first part of it, that is level sensitive. Similarly, when instead of using the levels, what I am doing, I am using the edges. It can have again 2 edges. It can have positive edge or it can have negative edge. So based upon the edges, if you want to see the design of flip-flops, so in this way we can design. Suppose this is your flip-flops. If I want to design this upper one, this point, if I want to see this positive one or positive one, this is called positive edges, where it transition from 0 to 1. So whatever the bits we are traveling, we are converting from 0 to 1. Then this particular part is called it as edges. So this is positive edge. Why we are saying positive? Because transition of the bits from 0 to 1. If it is happening, then we can say this is what? A positive edge triggered clock pulse. Okay. So similarly, if you want to give the reverse, if you want to give the negative edges, like if I want to design by using the negative edge, how can I design? I can go with same phenomena. Here I am saying this one. Instead of taking the positive one, if I am taking the negative end like this, I'll design over here. See, this is a clock pulse, right? Here what I am taking instead of positive 0 to 1, I am taking 1 to 0. The bits which are changing from 1 to 0, this one. Transition from the bits from 1 to 0, those particular part is considered to be the negative edge triggered. So this is also a negative edge triggered. So when your bits are changing from 1 to 0, so 1 to 0, when I want to see this particular part, then this type of edges are considered to be the negative edge trigger clock pulse. So in clock pulse we have two things. One is level sensitive, level is single, 1 and 0, 1 and 0. If it is lower, 0. If it is higher, 1. If it is lower, 0. If it is higher, 1. So this is levels. Edges, again it is two types. One is positive, another is negative. So positive means transition from 0 to 1. Those are positive. These are positive. So again these are positive because changing from 0 to 1. So again it is changing from 0 to 1. So these are called what actually? These are called positive edge triggered. Whereas if it is happening the transition from 1 to 0 likewise, then these kind of edges are nothing but negative edge triggered clock pulses. So this is the way we will take the clock pulses. So how it is going to happen, this edges and all that, when we come the detailed topic, we are going to learn in detail how the clock pulses is going to be generated. So thing is, you should know that positive edge and negative edge both. So first thing what we have seen the SR latch, that is the first part. In that we are having three methods of designing. One is active low, another is active high, next is the clock pulse. So in active low, what is the meaning of active low? When 0 is given, the latch is going to be activated or it is going to produce the output is high. When active is high, that means if you give 1, for that 1 your latches or flip-flop is going to get the output is high, or it is going to activate the flip-flop or latches. So now clock pulses means by giving the clock pulse, this clock pulse. This is called clock pulse. So it is two type in that, level sensitive or edge triggered. Level sensitive means these are levels, right? Edge triggers are again two category. This is the next two category of it. So by using this positive and negative edge, we are going to design that particular flip-flop or latches. So what is the meaning of active low? That means by using NAND gates, because by using NAND gate it is going to produce the output. Why? Because we know NAND gate truth table is what? When A, B is given, what is NAND gate output? AB bar. If it is 0, 0, 0, 1, 1, 0 and 1, 1. That means what is AND? AND means if both the input is high, output is high. Whereas NAND, if any one of the input is low, output is high, like this. And this is for 0. That means if you had 0 bit, he is producing the output, right? That means it is active low. So when we had NAND gate would symbol will be like this. So when you had 0, any one of the input is 0, output is producing high. So this kind of designing is called it as active low pin designing or active low gate level designing. Clear? Similarly, when you had active high is used for NOR gate. What is that NOR gate? How you are going to take the NOR gate? NOR gate can be taken by taking the two inputs value. So similarly, if I am taking my two inputs are A and B. Suppose I had AB like this. I want to write the output of A plus B. How do I do it? A plus B complement. That is called NOR. How do we write NOR? Like this I can write. Right? So what is its combination of that 0 0 0 1 1 0 and 1 1? What is a NOR statement? It's just reverse of OR. OR means what is A plus B? Here A plus B, if you want to write, it will be 0 1 1 1. NOR means reverse of A plus B. It is A plus B, right? A plus B bar means 1 0 0 0. So if both the input is low, then only output is high. So when you want to get higher bit, we are going to design by using NOR gate and active low by using NAND gate. So by using these gates, we are going to design all kind of latches and flip-flops. So in details how it is going to work and how we are going to design the latches and flip-flops, we will see in the next class. So in today's class we talk about the combinational circuit and the sequential circuit. Combinational circuit doesn't carry any kind of information regarding memory, whereas sequential circuit needed the memory. So that memory elements are nothing but like a flip-flops. So that flip-flops we can design by using the latches. So latches is just like opening and closing of the door. So when you open it, whatever bits of information is there, it is going to give particular circuitry. When it is close it, then there is no information passage. So that is cross coupled. How it is going to be cross coupled and what are the things? By using these three methods, first method and second and third, we are going to design for SR, and then we will follow for remaining types of flip-flop. Thank you.